Welcome everyone to Reimagine Mobility Podcast. I'm here with Fadi Abro from Stratasys. Fadi, thanks for joining me today. We're going to talk about something very interesting here as we talk about how do we see mobility going forward? How do we reimagine mobility? There's certainly the technology side, there's the consumer side, but very importantly also there's the manufacturing side, and you work in additive manufacturing that I would say maybe besides ADAS and electrification is a mega trend that not too many people are talking about, but really has been going on for quite a while. So please introduce yourself, tell us a little bit what you guys are doing, and then let's jump in and reimagine mobility together here.
Wonderful. Thank you for having me. I really appreciate the invites. I'll tell you a little bit about myself first. I went to school for engineering, a local college here in Detroit called Lawrence Tech, and I was getting ready to go down the path of engineering, focus on engineering, go into the automotive industry. About halfway through my schooling, I was like, I don't know that I want to be behind a computer all day, every day. and started to pivot to more entrepreneurial, engineering-related activity. Ended up more on the sales, account management, sales engineering side of the world. Started with a Japanese tier 1 supplier that does a lot of material handling. So if you've ever seen the automated vehicles that go through a factory floor, that's what I kind of started my career doing. Pivoted in 2010 or so to additive manufacturing, found a company that was doing that, again, here in Detroit. And in 2010, joined a company called Solid Concepts, which was eventually bought by Stratasys. So I've been at Stratasys and in the additive ecosystem for about 13 years. And a lot has changed. I'm sure we'll talk about all that here in the next couple of minutes. But as far as what Stratasys is doing today, we're in many different sectors. So as you can imagine, additive, like most manufacturing methods, has a home in all the major verticals that you can think of: aero, auto, medical, consumer products, you name it. And in auto, what we're specifically doing is enabling the manufacturing of the vehicles. That's the new mega trend, as you mentioned, and with ADAS and some of the Industry 4.0 things that are happening. Additive is focused more on getting vehicles out the door. For many years, since the 80s, late 80s, Stratasys was born in 89. We've been working with the autos on the prototype and product development side of the business, so that the design studios and the folks who are more focused on designing the vehicle, right? Now we're focused on the people who actually get the vehicle to the consumer. So that is the most recent trend, and that's what we're doing today.
So Fadi, when we're talking about additive manufacturing, right, I have this thing in my mind. I need a spare part for my vehicle that I'm driving. The dealership doesn't have it. The local parts store doesn't have it. So I call this person who has this printing machine in their basement or in their garage, and he or she's going to print this for me. How strange, how out of this world thinking, how twisted is this? Or what's reality? And maybe also, what is the future as we reimagine mobility? Share a little bit about that.
Yeah, look, I would never call you twisted to your face, right? I think it's a good thought, and it's a place that most people jump to. If I can make a prototype, why can't I just make the end use part with that same machine that makes the prototype? And in most cases, it's a fair thought, and it's an appropriate thing to think about. It becomes much more of a reality when you look at spare parts, aftermarket, low volume bespoke vehicles. Those are places where, of course, if you're looking at them, they're low volume by nature, and then they marry themselves to additive really well. I will say the idea of somebody doing it in their garage or in their basement is probably unrealistic even in the future, because what you're trying to produce is an industrial part. Sort of like saying, could somebody just buy an injection molding press or a stamping press and put it in their garage? Theoretically, yes, but it's probably not an ideal place for it. What's happening today, and what's most likely to continue as a trend, is that the OEMs themselves or their suppliers buy this equipment, industrial level equipment, not hobby level type 3D printing stuff. They put those in the factories, and those are the places where spare parts come from. So a dealer needs a 92 Corolla component. They send the data or send the request. A part comes back that's 3D printed. They either finish it to the paint spec or some third-party supplier does that down the line. That's the scenario that OEMs are working through today. There is a barrier. You have a technical audience. I want to speak to that. The big barrier is mostly around certifications. The prints, the paperwork, the standards have all been made on a different manufacturing method for that part originally. And also, even if the material is the same, you're producing it in a different way. You're extruding it, or you're photo curing it, or whatever it is. You're making it in a different way. Even if the material properties are superior to that of the production component, without the proper certs, it's hard to just go one for one, make an insert. So what a lot of the companies, Toyota, GM, you name it, they're coming up with standards where they can say, okay, look, if we've used this material and this manufacturing method, this process and additive, and this material and additive coupled together are equal and one-to-one. Therefore, spare parts or even bridge to production becomes a reality. So, in the COVID era, we all deal with supply chain issues. Maybe I need to get the first 400 cars rolling, and I'm waiting on parts that are maybe coming from China, Vietnam, wherever. And those parts, let's say 2 to 3 components, are going to slow down your entire build for a month. You could supplement that with additive if you have these certs kind of thought about and figured out in the beginning. So that's the main challenge for the OEM today. It's not so much a material challenge. It's not so much a product problem. It's a cert problem.
Understood. The testing and validation that automotive parts very rigorously have to go through. So let me take you back maybe like 10 years. There was some sort of a military conference where the generals and sort of the visionaries there were talking about what they're looking at. And this was a big topic, right? How do we get spare parts out into the field where war is going on, right? In the conflict zone. Certainly we're not going to have a large hall with all sorts of potential spare parts there that you can just go in, grab it, and go out that you may have somewhere here in the U.S. on a base, for example. But you need flexibility, you need to get something done quickly, and you need to fix it fast. So this was brought up, and it's ever since made a lot of sense to me. It sounds like we're for sure moving there. What do you see happening over the next 5 to 10 years? Are we getting more material? Are we getting even more parts than what is possible today? Because the machinery, the equipment that you guys are producing and supporting is getting better. Is it because the industry, the OEMs, as you just mentioned, become more interested in it? Again, lower spare parts, flexibility, faster turnaround, no inventory, all of this. Share a little bit and tell us, what can we expect over the next 5 to 10 years?
Yeah, let me just comment on your government example. The 2 biggest segments for Stratasys today are government and automotive.
Yeah.
So it's serendipitous that you speak about that 10 years ago, because that's what you imagine the fleets and aging equipment that's out there when it comes to the Navy or the Air Force, equipment that was already low volume by nature in the production process long ago, but now is an even lower volume when you talk about spare parts.
Right.
So that is a huge market for us, and one where we are solving that problem today. They're able to pivot a little bit easier in terms of standards, simply because they write the standard. It's not like automotive where there's a consortium standards.
Right.
To your point about what's coming, I just have to go back a little bit before we get to what's coming. Mentioned I've been an additive for nearly 13, 14 years. What's really changed in that time has been the properties of the materials.
Nice.
And the quality and accuracy of the equipment. So the engineering part has been solved, right? Can we get the product to be as strong as it can be? Can we get it to be as accurate as it can be? That's what's changed a lot in the past 10 years. What I expect in the next 5 to 10 years is going to be 2 things: software and throughput. I'll address throughput first. even though we're talking about low volumes, as everyone probably listening understands, low volume for auto could be 30,000. That's still a pretty high volume for additive. And so the focus needs to be around how do we get more out of this equipment? How do we get better uptime, increase throughput, get more parts per hour out of the machine? So I expect us to go there. That has improved tremendously over the past about 3 years, but a lot left to go to keep up, even with the low volume, Corvettes and specialty vehicles, low volume sort of for the traditional autos. On the software side, there's a lot happening there. So software is a big enabler for every probably sub-industry of automotive. As you can imagine, I'm sure you've spoken to lots of folks in AI and in software development. For us, software can enable the use of additive in a couple of different ways. One is, I mentioned that 94 Corolla. Could we put the CAD in some AI that will just filter out all the parts that make sense for additive, put them in a bucket, help the OEM decide what to do with that from a spare part perspective? So rather than an engineer individually clicking on all 30,000 components in a vehicle to figure out which ones should be printed in additive. And then on the manufacturing side, something we haven't discussed yet that we can delve into if you're open to it is the manufacturing element. So these are the tools, the jigs, the fixtures that help put the car together. AI and generative design can be used today to help an operator make a more ergonomic tool. So if you have to assemble a door and the hinge on a vehicle, you typically use a jig or a fixture to hold it in place or check the fit or look at the gaps. All that is done with tooling and fixturing that is essentially one-offs. They're very expensive to make. CNC machinists don't want to make them because they want their CNC machines producing production parts. And the complexity on those things tends to be very, very high. So you can imagine a world where software enables that, where you say, okay, this is the operation I want to create, or this is the operation I want the operator to execute on. And then it draws the tool, sends it to the printer, and then that operator has a tool that helps them manufacture the vehicle.
Interesting. So when I listen to this, two things pop in my head, right? One, a tremendous opportunity for society maybe as a whole, as we were talking about sustainability. We need less molds, we need less jigs, we need a whole lot less of this because we can get all just to this one quote-unquote universal machine or printer, if I may call it for this. On the other side, I look at this and I listen to this opportunity, right? And I say, what about all these companies and shops that produce these jigs, right? That now essentially Stratasys and others in the industry could essentially eliminate. I mean, at the end of the day, maybe good for the environment, good for maybe capital employed as it relates to value, good for the OEM because he has to pay less tooling costs. But is this all true? And B, do you get pushback from some of the suppliers that do this that say, hey, it's nowhere near as good from a quality perspective as ours. It's not repetitive enough, et cetera, et cetera. Can you share a little bit on that area?
Not an unfounded fear, and a fear that we hear every now and then, like with any new technology or any enablement tool. I was in the AGV world, as I mentioned earlier. You can imagine how the forklift drivers felt about an automated vehicle taking things from point A to point B by itself.
Yeah.
Look, at the end of the day, what we're trying to do with additive is enable those suppliers. So why are you machining your jig out of aluminum when you could be printing it in polymer that's carbon reinforced, that's stiffer, less weight, better ergonomics? Oh, and by the way, it's cheaper and faster. So I don't necessarily want to do that work. That's not the role of Stratasys. The role of Stratasys is to make equipment that enables these folks to say, oh, I'm going to bring in this new technology and be able to support my core business. If my core business is making fixtures, if my core business is, producing robotic end-of-arm tools for a company that's doing a lot of automation, if my role is to make chick fixtures or I'm involved in CMM, I can bring in this equipment and enable my production process. Again, just the same way you would, when you buy a power drill, you don't throw away all of your other tools. They're different tools for different roles.
When we hear, you mentioned it before, right? Industry 4.0, very fit here for this, right? And we oftentimes listen to or we read about, for example, Tesla and how advanced their manufacturing is. They're always looking for the next thing on how they can squeeze out even additional efficiency, right? Reduce cost, increase efficiency, throughput, all those. I think what we're talking here is very much probably fits exactly into this. Share a little bit, what are currently the limitations? I know you talked about the material, right? A big cost today certainly is the frames for cars, right? A big cost is when we talk, for example, one of the mega trends we touched earlier upon electrification, the battery enclosure, right? It has to be of material that is, from a thermal management, is able to handle the heat and the heating and the cooling in both cases. And I don't see additive manufacturing there yet, but again, I'm not the expert, you are. So can you put a little bit of light on that space?
Yeah, I will admit that we've had about 30 years in additive to hone in and fine tune the polymer solutions. So all the plastic solutions out there, whether it's from Stratasys or our competitors, are at the top tier level if they're in the industrial space, just like anything else, right? A moped and an F-150 are two different classes of vehicle. So we're in the industrial space. Others like us and our competitors who are in the industrial space, we have had a lot of time to fine tune the polymer side of business and make that as efficient as it can be. Still have ways to go on throughput. Still need the OEMs to help us with certifying these materials for production uses. On the metal side, it's still a low maturity space. The technology has a niche. If you're making rocket equipment, if you're making aerospace components where cost is not so much a factor because you're making one or two, or it's, as my counterparts in aerospace say, it's going one way, meaning it's a missile or something, it's just never coming back. It's a much better environment for additive because they cost is not so much a factor. So while metals is still in a space where it can contribute to some segments, in auto, we find that most of the contributions are in motorsports. Sort of mirrors what aerospace does, right? A race car is an upside down plane. So it makes sense in that kind of high dollar one-off type of environment where metals would make sense. The technology is just not there yet to make these big sprawling frames and fixture or internal fixtures to the vehicle. So I would say for now, the traditional methods of doing that are just the right way to do them. I don't see a world, and even in the future, even if we can make metal machines that are huge, it's just not going to be as cost effective as stamping out sheets of metal.
Sure. Okay, two more questions for you. One, if you had to give a couple of examples of where you wish let's stay with automotive, or mobility in general, it could be aerospace, as we just mentioned, anything, boats, trains, planes, trains, automobiles, right? But if you were to highlight a little bit if you could convince some of the skeptics in the manufacturing space in those sectors of mobility, what would you try and highlight to them that you feel like is still something that they're constantly maybe saying, I'm not sure, I'm used to this for the last 20 years, and I sure the heck ain't going to change it, right? What are some of these things? Because we all experience it, right? New technologies, people that are in it for a while, they get used to something, and it's hard for change, right? It's hard to change until we see it, then we say, gosh darn it, why didn't we do this 2 years ago when I first heard about it, right? So what are some of these things you wish you could have a better ability, I guess, so to speak, to convince them that this is working and it is doing what you need it to do?
Yeah, thank you for the great question and opportunity. I mean, obviously, this is what keeps me up at night, right? How do we get more adoption in additive? And I will say we are blessed at Stratasys. So many OEMs have put their trust in us: GM, Toyota, Ford, Tesla, BMW. These are all big customers of our key customers. I have people on my team who are solely assigned to those customers because of their adoption and their growth and their ability to implement the technology. Where we have struggled actually is in these larger tier ones. So it's ironic that some of the tier twos have adopted because they see it and they go, oh, well, for a couple $100,000, I don't have to buy another CNC, or I can, check my sheet metal components and make sure they're not out of spec with a easily printed check fixture. But the big tier ones are sort of just a little bit stuck in limbo and are not sort of making this big jump. So if there's tier ones listening out there, I mean, I would encourage you to look at additive in three ways. One is the prototype side of the world. You're likely already doing this in some form, whether you're outsourcing or you're doing it on a hobby level printer. That design phase, no matter how good simulation gets, there are going to be times where we have to make a physical representation of the part that we have then to either show to a customer or to a focus group or for a commercial. You're going to have to make that part physically at some point. So the design side is number one. Number two, which is to me the biggest low-hanging fruit today, I've talked about it a lot in this interview, is the fixturing and the jigs. I mean, I walked through, you name it, Lear, Martin Rayo, Valio. You walk through these companies in their production floors, and it's all machined fixtures that cost, let's just say on average $3,000 to $10,000 a fixture. We're seeing, the OEMs are telling us this, right? We're not making it up. The OEMs, GM, Ford, and Toyota comes to us and says, hey, we've put these in our plants, and we're saving about 90% per fixture. So 90%, so that's, you go from 3,000 to 300, and you're able to do that by just simply adopting this technology. To me, again, very low-hanging fruit. We don't talk about it a lot because it's not as sexy, right? The fixturing of the vehicle is not as sexy as the actual parts going on the car. And then the third way is this pre-production spare parts way that is going to require collaboration with tier ones eventually. The OEMs may give us a standard and say, yes, this can be used for blank spare parts. We still have to go to that OEM or that tier one who supplied that part to begin with and work with them on that. So those are kind of the three categories I would implore everyone to think about who isn't already implementing additives.
That's good. Very enlightening, very interesting. All right, last question, not related to Stratasys or the technology, but what's going to be the next car you're going to buy and why?
Man, it's a great question. I'll tell you, I'll probably answer this longer than you need, but I love cars. So I'm a big muscle car guy for a long time. I sort of made a compromise. I got a Charger right before I got married, before I bought my wife her wedding ring. I made sure to get my Charger for myself. And hopefully she never hears this. And I loved that car for a long time. Then we had kids. You can see some of them up here in the pictures. We had kids, so I had to opt for a Yukon for now. But my next car, assuming when the kids are a little bit older, is going to be some muscle car. I would say if I had a blank check, like a 69 Chevelle probably would be the dream car, something I can refashion on the inside with some additive parts maybe.
Okay.
That would probably be the dream car. Realistically, next car will probably be an EV SUV is my guess.
Okay. I just want to say, I mean, muscle, it sounds like muscle for you is internal combustion engine, not necessarily like a Tesla plant, if I want to quote one of your customers' products here. So interesting.
Yeah,
interesting.
Detroit raised, it's hard for me to think of muscle as EV, although
sure.
I don't see a reason. Like, I guarantee my wife's next car will be an EV car because she just goes to work and comes home, right?
There you go.
It's like a 30-minute drive round trip. So it's like, why not make the investment?
Yeah, very good. Fadi, thank you so much. Very insightful, very educational for me. I know this will be very educational, interesting to hear by all our listeners and viewers. So thank you so much for your time.